Okay, hello everyone. Let us continue the third part of today's class. Okay, in the beginning of the class, let us see new announcement. Okay, so it is the final exam, final exam announcement. Hello everyone. According to the school calendar, June 11th to 17th, 2022 is final exam week. Our final exam takes the form of taking home. I will upload the exam questions to the eCourse 2 website on June 11th, 2022. Please send the answers to my email address comwcu@ccu.edu.tw at the latest by June 17th, 2022. Please note that this is still an exam and you are not allowed to discuss it with anyone during the answering process. Best regards, Wei Zhen. Okay, so let us continue the progress. Okay, so in the second part, we have taught to chapter 4 slides, page 175 to page 228, reference 58. Okay, so let us go to page 175. Okay. So 175. And let us go to reference 58. Okay. Okay, so reference 58 is a book written by Papolis and Pillai. So the title of the book is Probability, Random Variables, and Stochastic Processes. Okay. The publisher is McGraw-Hill, Europe, and it is 4th edition in year 2002. Okay, let us go back to page 175. Okay, so reference 58 given by, okay, u of t is equal to summation L is equal to negative infinity to infinity u of L over W times sine of pi W times t minus L over W and divided by pi W times t minus L over W. Okay. This well-known result goes by a variety of names, including the Nyquist sampling theorem, Shannon sampling theorem, the Nyquist-Shannon sampling theorem, or simply the sampling theorem. Okay. However, if you had learned the principles of communications, you may heard another version of the sampling theory. Okay, said that if you sample a signal at a sampling frequency which is greater than or equal to 2W, okay, where W is the bandwidth of the signal, okay, then you can reconstruct the signal by using this equation. Okay. Excuse me. So it is straightforward to show that the Fourier transform of u of t, which we denote by capital U of f, is given by capital U of f is equal to 1 over W times summation small l is equal to negative infinity to infinity. U of L over W times exponential negative J2 pi FL over W. If the absolute value of f is smaller than or equal to W over 2, and capital U of f is equal to 0 otherwise. Okay, I think it is very easy to derive equation 4.44 based on equation 4.43. Okay, you only need to use the Fourier transform. So I do not plan to teach you how to derive this equation here. Okay, using equation 4.12, it follows that. Okay, let us see equation 4.12. Okay, so in equation 4.12, we can see that r of t is equal to the integral from negative infinity to infinity, capital C of Tf times capital U of f times exponential J2 pi ft df. Okay, so let us go back to the page 175. Okay, not this page. Okay, 178. So it follows that small r of t is equal to the integral from negative infinity to infinity, capital C of Tf times capital U of f times exponential J2 pi ft df. Okay, so you can see that it is taking the inverse Fourier transform, and plus z of t, okay, where z of t is the noise. Okay, then we can use the result in equation 4.44. Okay, first we know that capital U of f is not equal to 0 only when the frequency is between negative W over 2 and W over 2. So the range of the integration can be changed to negative W over 2 to W over 2. Okay, here. And capital C of Tf remain the same. And capital UF is equal to 1 over W. Okay, here. And summation L is equal to negative infinity to infinity. Okay, here. And U of L over W. Okay, I should say small u of L over W. Okay, so here. And exponential J2 pi ft. Okay, here. Exponential J2 pi ft. And times exponential negative J2 pi fL over W. So here is the exponential J2 pi f. Okay, negative L over W. Okay, and df and plus z of t. Okay, then we rearrange the order of the symbols. Okay, so first let us see 1 over W is a constant. So we can move it in front of the order equation. And then we move the summation L is equal to negative infinity to infinity to here. Okay. And U of L over W to here. Okay. And the integral from negative W over 2 to W over 2. Okay. Copy to here. And the capital C of Tf copy to here. And the exponential J2 pi f times t minus L over W. Okay, copy here. Okay, and df and plus z of t. Okay, next let us go on. So this equation can be can be evaluated and equals to 1 over W. Okay, this. And the summation L is equal to negative infinity to infinity. Okay, this one. And the U of L over W. Okay, this one. And the integration in the brackets can be evaluated as this: C of t minus L over W, where C is the time variant impulse response function of the channel. And finally, plus Z of t here. Okay, plus Z of t. Okay, then how do we derive this equation from the previous equation? Okay, let us look at the blackboard. Okay, and because I do not have a blackboard with me, so let me use the Microsoft Word instead. Okay, so please wait me a moment. Let me find out my note. Okay. Okay, so it is chapter 4 and page 178 to, okay, I need to use an N dash here. Okay, 179. Okay, problem 1. Okay. So it should not be bold. Okay, in equation 4.45, from step 3 to step 4. Okay, let us go back to the slide. Okay, what is step 3? Okay, this is step 1. Okay, step 2 and step 3 and step 4. Okay. Okay, we use the following identity. Okay, let us see this. Okay, the integral. So we just need to copy this and paste here. Oops. Okay, why is it bold? Okay, it should not be bold. Okay, and this is equal to okay, this term. Okay, such that is. Okay, so I call this equation 1. Okay, so subproblem A is equation 1 correct? Okay, as a student or a professor, you must always keep a doubt attitude when you read a book or a paper. Okay, any book or any paper is not always 100% correct. Okay, you should check it by yourself. So we need to ask a question: is equation 1 correct? Okay, you cannot say, oh, because it comes from the slides, so it is correct. Okay, this is not the answer. Okay, next, subproblem B. If your answer is yes, prove equation 1. Okay. If your answer is no, derive the correct identity. It should be a comma. Okay. Okay, solution. Not bold. It is left to you as an exercise. Okay, because it is only an integration, and maybe involve the inverse Fourier transform for capital C to small c. Okay, so I think it is a undergraduate level problem. Okay, so I think you should be able to solve this. Okay, let us go back to the slides, or let me save this file. Blackboard. Okay, Mimo. Okay, chapter 4, page 178 to 179, problem 1. Okay, good. So let us come back to the slides. Okay, so next step. Okay, it is step 4. Okay, let us continue to see step 5. Okay, step 4 and step 5 are very similar to each other, except here. Okay, L over W is changed to T minus L over W. And here, T minus L over W is changed to L over W. Okay, we can see the next page. Okay, where we have added a thermal noise term Z of T, and where a simple change of variables was used in going from step 4 to step 5. Okay, so let us see how to derive the fifth equation based on the fourth equation. Okay, so let me use the blackboard to show this. Okay, of course I need to use the Microsoft Word instead. Okay, so so this is chapter 4. Chapter 4 and page 179. And this is problem 1. Okay. Okay, in equation 4.45, from step 4 to step 5, we use the following identity. Okay, so what identity? Let us see. Okay, this one. Okay. Okay, this one. Okay, without the plus Z of T. Okay, so it is equal to this one. Okay, please note that we need to include a summation here, because when changing the variables, okay, you may modify the summation. For example, the name of the variable, or the lower limit, or the upper limit of the summation. Okay, so we need to include the summation here. Okay, so I call this equation 1. Okay, so let me check if this equation is correct typed, or correctly typed. Okay, good. So let us see subproblem A is equation 1 correct. Okay, ask yourself again. Okay, so subproblem B, if your answer is yes, prove equation 1. If your answer is no, derive the correct identity. Okay, let us see the solution. Oh, sorry. Okay, the solution is it is left to you as an exercise. Okay, so because it is only only a simple change of variables was used. Okay, in going from step 4 to step 5. Okay, so it is again an undergraduate level problem. So I think should be able to solve it. Okay, if you do not know how to solve it, you can discuss this problem. Okay, and the previous problem with your classmates or with the teaching assistants. Sorry. Okay, so let me save this file. Okay, chapter 4, page 179, and problem 1. Okay, good. So let us go back to the slides. Okay, and finally, from step 5 to step 6 is a very simple step. We only need to move this constant 1 over W to here, okay, in front of C of T L over W. Okay, and add a pair of brackets here. Okay, the remaining terms are the same. Okay, so we have seen this page before. Okay, if we now assume that the channel impulse response duration is Tm, then the number of simple periods in Tm, L is given by L is defined as Tm over Ts. Okay, because one simple period is Ts, and the total channel impulse response duration is Tm. So when you use Tm divided by Ts, you will get the number of simple periods in Tm. Okay, so it is very intuitive. So it follows that C of T L over W is not equal to 0 only for L is equal to 0, 1, etc. to capital L minus 1. Okay. So in other words, the channel impulse response has capital L multipath. Okay, so equation 4.45. Okay, let us see equation 4.45. Okay, is this equation okay on the previous page? Oh, sorry, on the previous 2 pages. Okay, so equation 4.45 becomes R of T. Okay, here is the R of T, and we only need to change the lower limit and the upper limit, okay, to 0 and capital L minus 1. Okay, and the remaining terms are all the same. Okay, you can compare these two equations, these equations and these equations. Okay, only the lower bound and the upper bound of the summation are changed. Okay, the other terms are all the same. We now okay, so this should be a period. Okay, so let me change it. Okay, period. Okay. Okay, so I will upload the new latest version. Okay, it is 25 minutes. See you next time. Goodbye.